What happens after century-old trees come crashing to the forest floor? Today, join RaWMachines as we uncover the remarkable journey hidden behind the life cycle of old-growth timber. From the decisive cuts made deep in the forest, to the advanced sensor-driven systems of Idaho, and finally to a traditional Swiss sawmill where human intuition still outperforms artificial intelligence. From the wilderness to the factory floor, every step of the process will be revealed. It all begins in the vast forests of the Pacific Northwest. Here, our logger is performing a technique that demands absolute precision. Watch until the end and see if you can guess what it is. To control the direction of the fall, he first makes a V-shaped notch on the front side of the tree. This cut acts like a hinge, guiding the tree to fall precisely in the intended direction. The same process is repeated on multiple trees positioned along the planned felling line. However, the logger intentionally leaves a portion of the hinge wood intact on each tree to maintain control over its movement. The key lies in what is known as the trigger tree. This is the tree located at the highest point on the slope. Once the back cut reaches roughly 3/4 of the way through the trunk, the tree's center of gravity shifts and it begins to fall. Almost instantly, its momentum is transferred to the second tree, then the third, and the others that follow. The result is a remarkable display. 4 or 5 towering trees come crashing down within seconds, creating a powerful chain reaction that shakes the ground. But felling the trees is only the first step in a much larger production chain. Soon afterward, specialized logging trucks begin transporting the timber out of the forest. These massive vehicles are designed to haul dozens of tons of logs across rugged and challenging terrain. Convoy after convoy rolls onward, carrying tree trunks from their natural environment to modern industrial facilities. Their destination is the Idaho Forest Group Mill in Lewiston. Even from the outside, the scale of the facility is striking. Vast log yards stretch as far as the eye can see. Trucks move in and out continuously. The sound of engines, the hum of machinery, and the scent of freshly cut wood combine to create the distinctive atmosphere of one of the largest wood processing facilities in North America. The log yard is the first gateway into the production process. In the past, sawyers relied on visual inspection of the bark, the feel of the grain, and even the sound produced by a light tap to assess the quality of a log. Today, that work is supported by an extensive network of sensors. Each log passes through a system of electronic scales, optical sensors, and 3D laser scanners. The system not only measures length and diameter, but also identifies natural curvature, the location of knots, and potential internal cracks within the tree trunk. Once the log is fully profiled, its journey inside the mill officially begins. The timber is fed directly into a rotary ring debarker. High-strength carbide cutting tools spin rapidly around the log, gliding effortlessly like a colossal apple peeler. The automated system dynamically self-adjusts its tool pressure, ensuring the knives cut exactly to the required depth to strip away the bark without ever scoring or damaging the valuable log core inside. Once the log is stripped clean, it is fed directly into the head rig, the undisputed heart of the entire mill. Here, a massive efficiency breakthrough takes place through advanced curb sawing technology. Instead of forcing a naturally swept log through an artificial, perfectly straight cutting path, the saw blades shift dynamically to follow the natural contour of the timber. While it sounds simple, this critical engineering adjustment significantly maximizes fiber recovery rates. Furthermore, these modern saw blades feature an ultra-thin kerf profile. The cutting gap they produce is roughly half the width of older, legacy systems. This technical edge means far less wood is wasted as sawdust, leaving more premium material to be turned into high-value products. Each pass executes in a fraction of a second, driven by thousands of continuous background calculations, running simultaneously to ensure peak operational yield. After the primary cut, the squared timber sections, cants, continue through a series of gang saws, where they are further processed into smaller boards and lumber products. Every movement in this stage is closely monitored to ensure compliance with strict production standards. If sawing timber is a demonstration of industrial power, then the utilization of byproducts is a reflection of modern industry at its most intelligent. IFG does not simply produce lumber. It operates a circular ecosystem in which the life of the forest is renewed through even the smallest products it creates. After completing the primary sawing operations, the lumber is still not ready to be shipped. It retains rough edges, the natural curvature of the original log, and various imperfections that developed during the tree's growth. The next stage is edging. Here, high-speed saws remove the uneven outer edges, creating straight, clean, and uniform sides. Immediately afterward, the trimming system takes over. Rather than relying on human judgment alone, high-resolution cameras scan the surface of each board, instantly identifying defects or flawed sections at either end. Precise cuts are then made automatically, ensuring that every piece of lumber leaving the production line meets the highest standards of quality before entering the most rigorous inspection stage. At IFG, modern technology does not replace the role of people. Instead, it enhances and celebrates the value of human expertise. Lumber is graded into several categories, including select, construction, and standard. Although automated systems perform most of the measurements and evaluations, experienced inspectors still examine each board by hand. Accuracy here is not defined solely by data and numbers. It also relies on professional judgment developed through years of experience. It is a seamless blend of traditional craftsmanship and advanced automation. The wood now has its shape, but it is not yet ripe. Inside, the moisture content is still high. If left untreated, the wood will warp, crack, or even decay over time. Therefore, the wood must undergo the drying phase. Depending on the species and thickness, this process lasts from a few days to several weeks. Each stage is pre-programmed. The heat is increased slowly, held at the peak, and then lowered under control to prevent thermal shock. From a natural moisture content of about 50%, the wood is reduced to 15 to 19%, the ideal stable level for construction and furniture. If you listen closely in the drying chamber, you will hear the wood breathing, a very faint crackling sound as the wood fibers contract. The workers call this the sound of the wood maturing. When the chamber door opens, white steam billows out. The wood is lighter, more stable, and ready for the planing step. In the planing mill, cutter heads spin at speeds exceeding 10,000 revolutions per minute. They shave away layers of wood no thicker than a strand of hair, yet that is enough to transform a rough surface into one that feels smooth as silk. The lumber is then automatically sorted, stacked, and bundled into large units. Steel straps secure each bundle, while barcodes and traceability labels are attached to ensure full product tracking. Every bundle of lumber now carries its own production record. Manufacturers can trace where it was processed, which raw material batch it came from, and every stage it passed through before reaching the customer. From Idaho, these products are shipped around the world, from construction sites across the United States to factories and development projects in Japan, Germany, Australia, and many other countries. In another corner of the mill, even the smallest particles have value. Sawdust is compressed into biomass pellets, a clean-burning fuel that serves as an alternative to coal. Wood chips are sent to paper mills or particle board manufacturers. Tree bark is repurposed as landscaping mulch for residential areas, while planer shavings are recycled into fiberboard and other engineered wood products. The mill's energy system is powered in part by its own production byproducts, creating a highly efficient closed-loop cycle in which wood helps sustain the very process that transforms and renews it. Once pine and spruce trees standing tall in the forests of Idaho, they are now entering a new chapter in their journey. Through a combination of natural resources, skilled craftsmanship, and precision technology, they are transformed into essential materials that help build and sustain modern cities. But while Idaho's timber industry is defined by scale, speed, and technological power, a very different philosophy can be found across the Atlantic. It is a philosophy rooted in patience, precision, and a deep respect for the relationship between people and the forest. Our next stop takes us to Switzerland, home to August Breweiler AG. Here, we will discover a distinctly different approach to forestry and wood processing, one shaped as much by tradition as by innovation. The scale of this facility may not rival industry giants like IFG, but it embodies what many industrial engineers consider the gold standard of modern craftsmanship. This is not a mass production operation. Every order is planned and processed individually, often for highly specialized projects, luxury timber homes, handcrafted furniture, or architectural components that require precision measured down to thousandths of a millimeter. One, the log yard. The journey at August Breweiler begins with a grading process based on criteria that even advanced AI algorithms struggle to truly comprehend: wood species, origin, age, and most importantly, the harvesting season. The Swiss firmly believe that timber harvested during the winter, when the sap stops flowing and the cellular structure is at its most stable, yields unparalleled durability. This specialized wood is highly resistant to warping, possesses natural pest resistance, and retains the clean, serene characteristics of the high Alps. Two, debarking. The machinery at Breweiler is as modern as any top-tier facility in Europe. However, unlike IFG, where automated sensors operate autonomously, the technology here serves strictly to support human intuition. The debarking system utilizes micro-cutting heads programmed to prevent any surface scarring. Every minor deviation, even a matter of a few millimeters, is immediately detected and manually corrected by expert operators. Three, sawing and breakdown. The sawing phase is where the true, latent value of each unique log begins to reveal itself. Instead of prioritizing maximum throughput speed, the mill utilizes bandsaw systems capable of executing ultra-precise cuts with minimal material kerf loss. These thin-gauge blades drastically reduce the volume of wood lost to sawdust, maximizing the yield of premium fiber from the core of the log. Throughout the cutting process, the sawyer continuously monitors grain direction, knot placements, and the natural characteristics of the raw material. The objective extends far beyond sheer volume. It is about unlocking the exact potential of each log. Certain trunks are designated for heavy-duty structural components in construction, while others are earmarked for fine furniture or high-end architectural applications. Every single breakdown decision is guided by a profound, generational understanding of the material, a level of craftsmanship that algorithms cannot fully replicate. After the sawing process is complete, the timber moves on to the drying stage. Unlike the industrial kiln drying systems commonly used in North America, Breweiler continues to preserve the tradition of natural air drying. The boards are carefully stacked into large bundles inside well-ventilated storage sheds, sheltered beneath sloped copper roofs that protect them from harsh sunlight, while allowing mountain air to circulate freely throughout the year. This stage lasts for several months, and in some cases as long as half a year. The wood dries slowly and evenly, resulting in greater stability while preserving its natural color, distinctive aroma, and cellular structure. Inside the workshop, craftsmen still rely on familiar practices that have been passed down through generations. They run their hands across the surface of the wood to feel its texture, tap it lightly to listen to its resonance, and even detect traces of remaining sap by its scent. These are not random habits, but expressions of professional knowledge refined over decades of experience. Technology plays an important role in the process, yet the spirit of craftsmanship remains present in every stage of production. If Idaho Forest Group represents efficiency, scale, and the power of artificial intelligence, then August Breweiler AG stands as a testament to the enduring value of human skill. Two methods, two rhythms of work, and two distinct cultures, yet both share the same philosophy: to respect wood and to make use of it through understanding rather than exploitation. The journey of wood begins in the vast forests of North America, where spruce, pine, and fir species have grown resiliently over decades. Loggers arrive not as conquerors, but as craftsmen. They come fully equipped with safety gear and modern chainsaws. Yet the most critical factor remains their seasoned experience. The most vital phase is cutting the notch. The feller makes a precise horizontal cut, followed by a downward diagonal slice to form a large V-shaped wedge at the base of the trunk. This is the crucial technique used to dictate the exact falling direction of this wooden giant. Once the notch is complete, the logger begins driving bright red plastic felling wedges into the back cut. These wedges help lift the immense weight of the tree, preventing the chainsaw guide bar from pinching while helping push the tree toward its intended path. To achieve maximum precision, he even scales the rugged root flares to execute the cut from an elevated stance. Every single movement is calculated to ensure maximum safety within a tight and steep working environment. As the back cut slices through the final wood fibers, a sharp, echoing crack rings out. The soul of the tree officially detaches from its roots. This is not the end, but a transformation. One life cycle closes to open another journey, where the timber will go on to become a part of structures, products, and values shaped by human hands. Once the massive trunk rests on the forest floor, a different kind of raw power is unleashed. In the rugged timberlands of North America, there is no prouder icon than the Pacific P-16. the titan of the logging transport industry. With a gross vehicle weight that can skyrocket into hundreds of tons and a brutally powerful drivetrain, these beasts are engineered specifically to conquer hostile terrain that would stop a conventional truck dead in its tracks. Yet, every single haul is a high-stakes gauntlet. Narrow logging roads and a relentless succession of sharp hairpin turns demand absolute, unbroken concentration from the driver. In this environment, even the slightest miscalculation can trigger catastrophic consequences. After a long, grueling trek, the convoy finally arrives at the West Fraser LVL plant in Sutherland, Oregon. Here, the logs will enter production to be manufactured into laminated veneer lumber, LVL, a high-performance engineered material that serves as a cornerstone of modern structural construction. At the log yard, the massive tree trunks are unloaded one after another. Immediately afterward, they advance into the debarking system where their rugged outer armor is completely stripped away. The logs are then routed directly to the bucking station. Giant saws, operating with thunderous power, slash through the timber to divide the long trunks into blocks of perfectly uniform length. Boasting a massive production capacity of over 213,000 cubic meters of wood per year, equivalent to nearly 1.9 million veneer sheets. This processing station serves as the mechanical beating heart of the plant, operating non-stop to sustain continuous production. Every single cut is not just the establishment of a strict new geometric order, but also the vital preparation for a grand transformation from a raw entity of nature into a premium engineered material. Before facing the blade, the wood must undergo a thermal conditioning process. The bucked logs are submerged in large hot water vats, where the heat penetrates deep into the grain, softening the cellulose fiber structure and preparing it for highly precise peeling. This is the wood conditioning phase, which allows the timber to achieve ideal pliability, effectively preventing any splitting or tearing when it meets the steel blade. Immediately afterward, the log advances to the centerpiece of the facility's technology, the spindleless lathe. The log spins at an incredible speed, and beneath a razor-sharp knife, it begins peeling away continuous ribbons of veneer just 1/8 of an inch thick. From a solid, heavy log, dozens of ultra-thin wood sheets are generated with exceptional uniformity. This is where technology delivers its true value. The natural flaws found in rough-sawn timber, such as knots or twisted grain, are systematically managed and neutralized, replaced by uniform veneer sheets that boast a stable structure and precisely engineered strength. One, cutting and standardization. Once the veneer has been peeled into continuous sheets, it moves to the cutting and sorting area. Here, automated systems trim the veneer into standardized dimensions, most commonly 4x8 foot panels. Despite the high production speed, every cut must meet the precision required for the stages that follow. Two, inspection and grading. Next comes quality control. Each veneer sheet is evaluated based on its grade and moisture content. Sheets that meet specification continue on to the drying process. Those that fall short are redirected to other wood product lines, where performance requirements are less demanding. Three, waste utilization. A closed-loop system. One of the most impressive aspects of the operation is the way every remaining piece of material is put to use. After the valuable veneer layers have been removed, the remaining wood cores are chipped or reprocessed for other manufacturers, extending their useful life in new applications. Wood chips are sent directly to pulp mills, where they become raw material for the global paper and packaging industries. Even the bark and sawdust serve a purpose. What might otherwise be considered waste becomes a valuable source of biomass fuel, helping generate the energy needed to power the very facility that produced it. At West Fraser, when a tree is harvested, its value is never lost. It is simply unlocked and redistributed across a brilliant spectrum of engineered forms. After being cut and graded, the sheets of veneer still contain a significant amount of moisture from the original log. Before they can be assembled into LVL, they must undergo a drying process to achieve the ideal moisture content required for proper adhesive bonding. Inside the kiln, high-intensity blasts of hot air at around 400 degrees Fahrenheit are blown across the veneer layers. In just 3 to 4 minutes, the wood's moisture is brought down to standard levels. The roaring wind, intense heat, and the faint scent of sap create a harsh yet profoundly sacred working environment. The key lies in the balance. Overly damp wood will ruin the glue bond, while bone-dry wood becomes brittle and prone to cracking. Only when the exact target moisture content is met can the veneer layers bond durably and maintain their structural stability over time. If the drying kiln is a purification by fire, then the bonding stage is the moment of unification. The process begins in the layup area. Once the veneer sheets have reached their ideal moisture content, each one is coated with a specialized phenolic adhesive. Unlike natural lumber, where strength can vary from one section to another, every veneer layer here is carefully aligned in the same direction. With the grain running parallel, the layers no longer work against one another. They work together, sharing loads and reinforcing the structure as a whole. The assembled stack then enters a massive continuous press. Under pressures of roughly 300 pounds per square inch and elevated temperatures, the veneer layers are compressed and bonded into a single solid mass. The result is a nearly flawless surface, free of weak knots, devoid of twisted grains that cause warping, and empty of wasted voids. This is a clear testament to the power of modern technology, where nature is deeply understood and elevated to create sustainable value for the future. Even after being fused into a high-strength monolithic material, each LVL billet still requires a few final refining steps before it is ready to anchor structural engineering projects. continuous LVL billets are precision sawn to match the exact dimensional requirements of each specific project. Following this, they are stamped with structural identification marks and fully logged into the facility's product traceability database. Only the LVL products that meet absolute quality control standards are granted their passport to ship out of the plant. Once all quality inspections are complete, the finished products are strapped into tight bundles, wrapped in protective packaging, and staged for shipment to markets across the United States and Canada. Originating from the remote timberlands of North America, they will now make their mark on active job sites, prefabrication plants, and large-scale construction projects. And one of those destinations is a log home construction project by Discovery Dream Homes. Here, the LVL beams shed their identity as a mere industrial product to take on a brand new mission, becoming the vital building blocks of a sanctuary called home. The work begins with an inspection of the foundation. The foundation surface must be level, properly dimensioned, and within allowable tolerances. Next, moisture barrier sheets are laid over the foundation surface to prevent dampness in the concrete from seeping up into the wood. To ensure precise construction, each timber is marked with an identification code at both ends. The erectors simply read these markings sequentially from the outside in and from left to right. Each code corresponds to a specific wall location, log row, and installation sequence predetermined on the shop drawings. The first row of timber is always a half course, featuring logs cut lengthwise to establish a baseline for the entire structure. Depending on the foundation type, they are secured using specialized pins or anchor bolts to ensure rock-solid stability right from the very first layer. Each timber has a maximum length of about 16 feet. For longer walls, the proprietary timber lock wooden interlocking system is utilized. This mechanism functions through a combination of gravity and geometry, creating a self-tightening effect without the need for complex joints. Once the timbers are assembled, the joints virtually vanish from sight. One of the most important features of a modern timber home is its ability to resist moisture, block air infiltration, and maintain thermal efficiency. To achieve this, foam gaskets and sealing materials are installed between the timber courses throughout the construction process. As each new layer is added, the sealing system forms a continuous protective barrier. Once the components are compressed together, even the smallest gaps are virtually eliminated. The process is repeated around the entire perimeter of the structure, No joint is overlooked, whether it involves a full-length timber or a locking half-course. The result is an exceptionally airtight building envelope that helps reduce heating and cooling costs while eliminating unwanted drafts. To maximize structural stability, the timber beams are precision machined with a heavy-duty tongue and groove profile. In tandem with butyl tape and foam gaskets, this interlocking system allows the log courses to seat tightly together, significantly increasing the structure's resistance to water infiltration and air leakage. At the corners of the structure, builders drill holes downward through the timber rows and fill them to about half capacity with expanding spray foam. This precise amount is enough to seal all gaps completely without creating any back pressure. This process ensures that the corner dovetail joints are fully sealed, as these are typically the most easily overlooked spots. Only when a continuous airtight seal is maintained can the structure achieve long-term durability. To ensure an efficient erection process, the timbers are staged as close to their final installation areas as possible. Long timbers are stacked neatly on the subfloor, while shorter ones are stood upright to save space. Additionally, the electrical system is pre-integrated into each component. Conduit pathways, along with outlet and switch locations, are all predetermined, allowing for a much faster and smoother on-site installation. As more timber courses are added, the walls begin to take shape. In the early stages, many of the components can still be lifted and positioned by hand. But as the structure grows taller, ladders and scaffolding become essential tools. The work requires close coordination among the construction crew. Each timber section must be placed in the correct position and carefully aligned before the next course can be installed. The anchor holes are pre-drilled at approximately 60-inch intervals, while being positioned about 12 inches away from corners, doors, and windows. The tongue and groove are removed from the topmost timber row to create a flat surface for the beams or trusses. The tie rods are cut from the top of the wall down to the lowest anchor hole, then fitted with washers and guided into place. Throughout the construction process, the bolts are periodically inspected and tightened. For the compression spring system, the rubber pad is compressed by about 2 inches, just enough to keep the structure secure while still accommodating seasonal wood shrinkage or settling. A subtle feature of log home architecture is that door and window frames are never fastened directly to the logs. Instead, they are installed using seasoned hardwood splines, allowing the frames to float independently within the wall openings. This design ensures that as the house expands and contracts with the seasons, immense pressure won't bear down on the glass panes or jam the doors. The house does not fight against nature. It gracefully adapts to protect the peace within.